So when we did arc length, we set up a proportion. We said L, our length, out of all of the circumference, 2 pi r, equals the degree out of 360. And then multiplying both sides by 2 pi r gave us this formula. Okay, so area of a sector, you set up the same way, but instead of 2 pi r, you're looking at the area of the sector out of the total area of the circle, not the circumference. So instead of 2 pi r, it's area of the circle, which is pi r squared. So that's the only difference here. You'll see pi r squared instead of 2 pi r. Okay, so of course there's the whole definition. Let's go ahead and try one of these. Starting with a pretty easy one here, a 90-degree angle. Basically, you want to find the area of the circle and just take 1/4 of that, right? So you could just logic your way through it and do, okay, pi r squared and then divide it by 4, okay? Because that's a pretty simple one. If we use the formula, you'll see how that's basically the same thing. So the area would equal our degree out of 360, so 90 degrees out of 360, which is just 1/4, times pi r squared, area of the whole circle. Pi r squared would be, here, I'll write it out. My r is 10, I'll plug that in. Of course I square it, so this would become 100 pi. So simplifying that down, we've got 1/4 times 100 pi. Okay, so really, if you want to put that over 1, multiply straight across, you're doing 100 pi divided by 4, which is just 25 pi. I'm pretty sure that's what I have behind here. Yeah, if you want to write all of that down, you can. You don't need to, but just know the exact answer would be 25 pi. Now, if you put that in your calculator, it would give you the rounded answer, or you'll have to round it yourself. There you go. Okay, so let's try another one. Find the area of sector CMD. So I'm just going to write it down here. Let's do our formula. Here's my sector. This is 150 degrees, which means the central angle is also 150 degrees. So I'm going to do 150 out of 360 times pi r squared. So pi, my radius is 6, squared. From here, we just got to simplify. If you want to use your calculator to help you, you can put in 150 divided by 360 and press enter. And then if you hit math, enter, it'll simplify that fraction for you, save you a little bit of time. So that simplifies to 5/12 times, of course, this would be 36 pi. Okay, if we multiply straight across, 5 times 36 right there, so we'd get 180 over 12 times 1 is just 12 pi. Now, if you simplify 180 over 12, that just becomes 15 pi. That would be an exact answer. So it's not telling us how to write our answer here, so let's write it both ways, because you'll definitely have to know how to do it both ways. So let's approximate that and actually get a number. Plug that into your calculator, and you get approximately 47.1. Now it is area, so we'll say meters squared. Good. Okay, why don't you guys go ahead and try this one. You can pause it, try that, see if you get the right answer. I'm going to reveal the answer right now. Boom, there you go. There's even the work for you if you want to check it. So here would be your exact answer and then approximate answer. Okay, this is our last thing here. All right, so if you want to go ahead and add to your area formula, this will be the last one we're doing today. So this is the area of a segment, or if you want to put area of a circle segment, you can do that too. That's what we're talking about. So a circle segment is the region, as it says right here, bounded by an arc and its chord. So if you think of it as like a piece of pizza, we're looking at just the crust, basically. Okay, and it'll always be shaded so you'll know what it's talking about. So if you think logically, how could you find the area of a circle segment? Well, this is actually the formula. I put it up top, but I'll put it right here. Doesn't really look like a formula, but this is what you would do. You'd find the area of the whole sector, right? Like if I shaded all of that, find all that area, and then you just simply find the area of the triangle and subtract them, and you'll be left with this shaded part. So add to your formula this right here, area of the sector minus area of the triangle. Let me move this up actually. Okay, so let's do it. Let's first find area of our sector. So area sector, which should be pretty easy now. So we're doing 90 over 360 times pi r squared. So 10 squared would be 100, so 100 pi. And we did one like this already, so that's just 1/4 times 100 pi, so that ends up just being 25 pi. All right, that's the area of the whole sector. Let's also do the area of the triangle, which is base times height divided by 2. Now, since it's a right triangle, these are really, really easy because your base is 10 and your height is also 10 because they're both a radius. So we're just doing 10 times 10 divided by 2, so we end up with 50. Okay, now final answer then, we take area of our sector minus the area of that triangle, and we've got our final answer. So an exact answer would actually be 25 pi minus 50. That would be fully simplified. Now if you plug that into your calculator, you get the approximate answer, which would be about 28.5 square inches. All right, let's try another one, last one here. You'll see that these aren't always that simple. They can actually get pretty tricky. We're only going to do one like this, so don't freak out. I think you can do it. Like I put at the top, if your sector has a right angle, it's easy. Otherwise, it takes a bit of effort. So, okay, it's telling us to find segment CMD, so the shaded part right here, okay? So the way we do that, we first find area of the whole sector, area of triangle, subtract them, boom, we're done. Now, area of a sector, you guys can go ahead, if you want to pause it and try to do that on your own, go for it. I'm going to reveal the answer here. I think y'all are good on the sectors. So that would be all the work, which simplifies to 15 pi. All right, that part's not so bad. Now, if it says find the area of the triangle, because we don't have a right triangle, we don't automatically have our base and our height. We're going to have to find some things. So what I did is I drew the triangle out to the side. I'd recommend doing that. I feel like I might get cut off on this. This might have to go to another part. Sorry if that happens. All right, so I drew the triangle. I know, let's label what I know. I know this part is 6. So, okay, area of our triangle is base times height divided by 2. Well, do I have any of that information? I kind of have a base if you want to make this the base, but the height I'd have to find out here. And that's going to be really challenging to find. So what I'm going to do is kind of change my orientation, and I'm going to look at this as the base of the triangle, and therefore my height would be the perpendicular distance from this vertex to the base. That's going to make things easier because this is an isosceles triangle because these are both radiuses. So when I draw that height or that altitude, it's going to cut this angle in half. Okay, so if that whole angle is 150 degrees, cutting it in half, we end up with 75 degrees right here. Okay, so think about how you could solve this triangle. Ultimately, we need to find this side, and then we can double it, and we'll have the whole base. And we also have to find the height. Are you thinking trigonometry? I hope so. That's what we're going to have to do here. So let's maybe label this side as x. Let's find it first. So from this angle, got to think sine, cosine, or tangent. Well, that's going to be sine, opposite over hypotenuse. You might have to write SOHCAHTOA out to the side. So let's do that.